Until now, our programs have all executed sequentially. When the first line of code is executed, we move on to the second. When that's done, we go on to the third line, and so on. When there are no more lines to execute, the program stops. And every time we run the program, it's going to flow through the same sequence of steps in the same order. If we want to give our programs some flexibility in how they execute, we need to introduce the concept of decisions, which allow the program to run blocks of code based on certain conditions. To make decisions, our programs will use Boolean logic. Boolean logic is based on the idea of true or false, which means that our program can make decisions based on a yes or no question only. There's no maybe in Boolean logic. Is the amount the user entered greater than 10? That's either true or false. If it's true, we can execute a block of code. If it's not true, we can skip that block and move on with the program. A Boolean variable can only have one of two values, true or false. In Java, we use the data type Boolean to store these values. Boolean variables are generally named with a question or a statement that can be answered with true or false. Has car is true or false, right? She either has a car or she doesn't. The valid values you can store in a Boolean variable are true and false in all lowercase and no quotes. We'll be able to use Boolean variables for decisions, which we'll see as we go along. The other common structure in Java that can be used for decisions is a Boolean expression. A Boolean expression is a statement that evaluates to true or false. Like arithmetic expressions, Boolean expressions use binary operators, operators that work on two operands. For example, the addition operation takes two operands to find a sum. This particular expression evaluates to 40. The most common Boolean operations are comparisons, and you'll be familiar with these from your math classes. Relational operators also take two operands, but they evaluate to a Boolean value, making them a Boolean expression. For example, 15 is greater than 25 evaluates to false. It is false to say that 15 is greater than 25. There are 6 relational operators in Java. For our examples, we'll assume we have a couple of int variables defined. The first operator is the equality operator, equals equals. It checks if two values are equal. For example, age is equal to 17, which evaluates to false in this case. This operator leads to a really common beginner mistake, using a single equal sign instead of double equal sign. A single equal symbol always assigns a value to a variable, and a double equal symbol always checks for equality. When I speak code out loud, I always pronounce equals equals as is equal to instead of equals to make it clear which one I mean. Part of what causes problems is that using the assignment operator instead of the equality operator will often compile and run. It just won't work. That makes it a tricky error to find and fix. The next operator is the inequality operator, which is exclamation point and the equal symbol. Now that you're a coder, you can refer to that exclamation mark as bang. And I'm not kidding about that. We pronounce this combination bang equals. It checks if two values are not equal. For example, age is not equal to 17, which evaluates to true in this case. Less than and greater than work as you probably expect. These examples show that the two operands can be variables, literal values, or one of each, and that's true with all of these relational operators. And the last two operators are less than or equal to and greater than or equal to. Again, they work as you'd expect, but notice the symbols we use. In math, we got used to drawing specific symbols for these operations. But we don't have characters like that on our keyboard, so we have to type them the way we'd speak them. Less than or equal to is a less than symbol and the equal symbol. Greater than or equal to is a greater than symbol and the equal symbol. There are a few more operators we use in Boolean logic, which we call logical operators. These operators allow us to combine multiple Boolean expressions into a single, more complex expression. We'll look at these closer when we start writing decision-making code, but for now, here they are. Two ampersands, or what you probably think of as two and symbols, is the logical AND operator. It returns true only if both operands are true. This example evaluates to true if age is greater than or equal to 18 and age is less than or equal to 21. If age is too low or age is too high, the expression evaluates to false. It basically checks to see if age is between 18 and 21. The operator for OR is two vertical lines. These characters are called pipelines or just pipes. You can find them on your keyboard over on the right side just above your Enter or Return key. Logical OR returns true if at least one of the two operands is true. This example evaluates to true if age is less than 18 or if the isRegistered variable is false. This particular expression checks to see if the user is either too young or is not registered to vote. Last up is the logical NOT operator, which is that exclamation point, which we call bang. The bang operator inverts the value of a Boolean expression. If the expression is true, bang makes it false. If the expression is false, bang makes it true. There's actually another logical operator called exclusive OR, but we don't use that and we'll ignore it for now since this chart is probably confusing enough already. As I said, we'll make sense out of all these once we're able to start using them in our code. We often want to test the equality of strings, like when we ask the user to enter a password. We'll need to check if what they entered matches the password we have stored. If these variables were numbers, we could just use the is=to operator. But in Java, we can't use is=to compare strings. Actually, we can use it, but it's not going to work the way you expect, and it's not going to give you the results you expect. In short, just don't do it. Instead, we have to use a string method called equals, and we pass in the value we want to compare to. Incidentally, it doesn't matter which string we use to call equals method and which one we compare to. The result will be the same, so you could also write this as password.equals user password. It might not be clear yet why we're spending time on this, but understanding Boolean logic is going to make it possible to write code that makes decisions, and that's what we'll look at next.